Alright, learners, before us we have a mole concept problem from your specimen paper 4 2020. On question 6 you're going to see that. Now the question reads 5.95 grams of cobalt to carbonate were added to 40 cm cube hydrochloric acid, and of course concentration 2 moles per dm cube. Now we are to calculate the maximum yield of copper to chloride hexahydrate. But first, what is the number of moles of your hydrochloric acid? What is the number of moles? Now we have what? We have the volume of the acid as well as the molarity. So what do we know? We know that the molarity is equal to what? The number of moles divided by what? The volumes in dm cube. Okay, in dm cube. Now, what is the number of moles? The moles will be equal to what? The molarity multiplies the volume in dm cube, which is equal to what? What is the molarity? 2 multiplies what? The volume is 40. It's given in cm cube, so we convert it to 1,000. And that gives you 0.08 moles. Oops, I don't like this, so let me just raise it. Good. So we have 0.08 moles. So we come here, right, at 0.08 moles. Good. Now the next question, number of moles of what? Cobalt to chloride. The number of moles of cobalt to chloride. We know that from your equation, 2 moles of what? Hydrochloric acid gives you what? 1 mole of what? Cobalt to chloride. So 0.08 moles will give you what? A certain x, which is what? 1 times what? 0.08 divides 2. And the best answer there should be, of course, 0.04 moles. So we got 0.04 moles there. The number of moles of cobalt to chloride hexahydrate. Now, where is hexahydrate? We got it here. We have hexahydrate here. And 1 mole of what? Cobalt to chloride gives us 1 mole of cobalt to chloride hexahydrate. So 0.4 moles will still give the same thing, since the mole ratio is what? 1:1. So we got this. We got that. Okay. Now the mass of 1 mole of cobalt to chloride hexahydrate is 238 grams. So what is the maximum yield of this compound? What is the maximum yield? Okay, so we know that. I'm going to change my pen out of blue. So we know that moles is equal to the mass divides what? The formula mass. Okay, formula mass. But we're looking for the mass. So your mass gives you what? The moles multiplies the formula mass, which is equal to what? 0.04 multiplies the formula mass is that which is given to 38 grams. And multiplying all that together, I got my calculator here. I have my calculator. So 0.04 multiplies to 38, and that gives us 9.52 grams. So that is the maximum yield of what? So you have 9.52 grams. Good. Now we move to the second question. The number of moles of hydrochloric acid used. So we got 0.08 moles. Okay, but there's a trick here. Remember, 2 molecules give this mole. So 1 molecule is actually 0.04 moles. Okay, so that is for 2 molecules. Good, so be careful with that. Now, number of moles of what? Cobalt carbonate in this. So number of moles of what? Cobalt carbonate in 5.95 grams of cobalt to carbonate. So what are we going to do with this? We have what? Moles is equal to what? The mass over what? The formula mass, which is equal to what? 5.95 divided by 119, and that gives you what? So if you use a calculator, you're gonna have 5.95 divided by 119, and we have 0.05 moles. Okay, we're gonna have 0.05 moles. So what do? We put our answers there. Good. So we have that. Now explain how these calculations show that cobalt to carbonate is in excess. So we see that what the moles of what cobalt to carbonate is more than those of hydrochloric acid. Yeah, so you just tell them that was 0.05 moles of what? Cobalt to carbonate is greater than what? 0.4 moles of your HCl. That's it. That's how. There's actually another way that we can solve this to get the limiting reagent or the reagent in excess, but we're going to see that in another question. So learners, that is that about that question, and we're going to solve more questions and more concepts more on my channel. So I promise you that, and if you need any more help, you can just put your comments in our comment box below, or you can write me on my email, which is going to be put there. So anytime, I'm going to reach you out.